The nature of time and human perception. A shrug, a nervous smile, or a cryptic answer like we don't know. But maybe the question itself doesn't even make sense. It's not just that we don't have the data. It's that the very concept of before might not apply at all if time itself began with the Big Bang. Without time, there was no before for anything to happen in. Try wrapping your head around that. It's like trying to imagine the edge of infinity, a boundary that defines the start of everything and yet defies the logic we live by. What is time in our current universe? So what is time now in our everyday lives in the context of the modern universe? You might picture it as a straight line, a relentless march forward, breakfast, work, dinner, sleep, repeat. But science has revealed that time is far stranger than this simple human perception. Thanks to Albert Einstein, we now know that time is part of a larger entity called space-time. A fabric that weaves together both space and time into one continuous framework. This fabric isn't fixed and rigid. Instead, it bends, stretches, and warps in the presence of mass and motion. Have you heard of time dilation? It's one of Einstein's most fascinating predictions, and it's been experimentally confirmed. If you were to travel through space at nearly the speed of light, time would slow down for you relative to someone back on Earth. You could embark on what felt like a one-year journey and return to find that decades had passed here at home. This is no science fiction fantasy. It's been verified using atomic clocks placed on fast-moving airplanes and satellites. Time, it turns out, is flexible, more like a rubber band than a ruler. Underscore 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 underscore. Could time break, stop, or reverse? Could time break, stop, or reverse? And if time can bend, could it break? Could it ever stop? Could it even reverse? To explore these questions, we must go back to the early universe just fractions of a second after the Big Bang. At that moment, the cosmos was a seething soup of particles hotter than a trillion suns. As it expanded, it cooled and time appeared to march forward. Or at least that's what we believe. But some physicists question whether time always flows in the same direction. There's a concept called the arrow of time which says time moves forward because of entropy. The universe's tendency is to evolve from order to chaos. A broken glass doesn't reassemble itself. That's entropy at work. This process gives time its one-way street. But what happens if the universe reaches a state of maximum entropy? Could the arrow of time fade or even flip? It's a mind-bending possibility that forces us to rethink everything we believe about time's flow. Underscore 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 underscore. Time and black holes. Time the same everywhere? Let's take this even further. Is time the same everywhere? Remarkably, the answer is no. Consider black holes, those mysterious monsters of gravity where the known laws of physics begin to unravel. Near the event horizon, the boundary beyond which nothing, not even light, can escape, time behaves in ways that defy our intuition. If you were to fall toward a black hole, hypothetically of course, time would slow down for you relative to a distant observer. To someone watching from afar, you'd seem to freeze at the edge of the black hole, suspended in time. But from your point of view, everything would feel normal until you cross the event horizon and plunge into the unknown. Inside lies the singularity, a point where density becomes infinite and our understanding of space and time ceases to function. Some theorists suggest that time might end there or morph into something we can't even conceptualize. In this way, black holes are like cosmic cul-de-sacs where time itself hits a wall. Could time end everywhere? But what about the universe as a whole? Could time end not just locally in a black hole, but everywhere? Underscore 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 underscore. The future of time in the universe. The future of time in the universe is one of the most profound questions humans can ask. To answer this, we must look ahead into the future of the cosmos. Scientists have outlined a few possible scenarios for how the universe might end, each with dramatic implications for time. One possibility is the Big Freeze. In this scenario, the universe continues to expand, driven by the mysterious force known as dark energy. As galaxies drift farther apart, stars burn out, and everything gradually cools to near absolute zero. Trillions of years from now, we could be left with a cold, dark, and silent cosmos. If nothing changes, does time still have meaning? Some physicists argue that in such a lifeless universe, time would become irrelevant, a ticking clock in an empty room, marking a rhythm no one hears. Another scenario is the Big Crunch, a less likely but still captivating possibility. If the expansion of the universe eventually halts and reverses, everything could collapse back into a dense point, a mirror image of the Big Bang. In this dramatic implosion, time as we understand it might come to an end. But here's the twist. Some theorists believe a Big Crunch could trigger a new Big Bang, launching a new universe with a brand new timeline. In this cyclical model, time would not be a line, but a loop, endlessly repeating birth, expansion, collapse, and rebirth. This breathtaking idea suggests our universe might be just one of countless cycles, each with its own beginning and end. Underscore 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 underscore. Time in the multiverse. Time in the multiverse raises even deeper questions. What if time isn't even universal? What if our concept of time applies only to our universe and doesn't hold in others? This brings us to the multiverse theory, a radical but increasingly considered idea in modern physics. Imagine our universe as a single bubble in a vast cosmic foam. Each bubble is a universe with its own physical laws, including its own version of time. In some of these universes, time might flow backward. In others, it might loop or branch like a tree. This idea arises from theories of eternal inflation which suggest the universe underwent a rapid expansion in its earliest moments, and in some regions this inflation never stopped, giving rise to countless new universes. If true, then time as we know it is just one version among an infinite menu of cosmic timelines. Can you imagine a universe where time doesn't exist at all? It's a concept that stretches the limits of human imagination. Underscore 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 underscore. The Hubble tension and the Big Rip. The Hubble tension and the Big Rip add new wrinkles. In fact, even our current understanding of time is being challenged. In 2023, astronomers noticed something strange. The expansion of the universe seems to be accelerating faster than expected. This discrepancy, known as the Hubble tension, suggests our current models of the